Hey guys, so what we're going to work on today has to do with bonding. And for bonding, I want y'all, first of all, I need y'all to be able to see the board. So I want y'all to be able to predict the charge something forms and then tell me why it forms that charge for ionic compounds. And then for covalent compounds, I also want y'all to be able to predict how many bonds it's going to form by sharing electrons with another nonmetal, okay? So let's get started. In some previous classwork, I asked y'all to tell me the charge something forms and then explain why it forms that charge based on the valence electrons. So let's look at oxygen. And oxygen, we're going to count up the number of valence electrons. To remind you how to do that, we're going to look at the periodic table. I'd honestly suggest that you use the one you used for electron configuration, but any periodic table works. And you would count left to right the number of squares it takes to get to your element, skipping over that middle D section because those are on a different energy level. So for oxygen, it's way up here, so we just count 1, 2, 3, 4, 5, 6. It's 6 squares across. So oxygen has 6 valence electrons. Remember, we represent that with our little dots. Okay, I don't like the way that one looked. So we represent that with 6 dots. And then we think about the octet rule. And the octet rule states that you have to have 8 valence electrons in order to do that. Atoms are going to gain, lose, or share electrons to make that happen. So for oxygen, it has 6 valence electrons. It can do one of two things. Either, based on its inner rings, either oxygen can lose 6 electrons, okay, or it can gain 2 more electrons. So, and let me write gain. So what do y'all think, guys? What do y'all think it's going to do? Which one do you think is going to make more sense? Losing 6 or gaining 2? Losing 2. So, well, it's not losing. The 2 was what I heard. So gaining 2 electrons is what it's going to do. Now, just think about it. It's kind of logical. If you have to lose 6, that's probably going to take more effort or energy than gaining 2. So whichever one requires the least number of electrons is going to be what it's going to do.
What if they're equal?
So if they're equal, like these have 4 valence electrons. So it can gain 4 or it can lose 4, and it can give you the same result. They're basically the same amount of energy. So it's going to depend on what they bond with. And so that's why this column says +4 and -4. But you're not going to write that on your periodic table because what you're using this for, lead and tin are considered like the transition metals with charges that vary. So you're not going to always have that set number, okay? But yeah, when we're looking at the number of bonds, carbon, we're going to be thinking about that plus and -4. Okay, so oxygen can either lose 6 or it can gain 2, but gaining 2 is what oxygen does. And when it gains 2 electrons, okay, it then, either by taking the electrons when they transfer or by sharing, oxygen then has a full set of 8 valence electrons. And when it gains 2, oxygen makes a -2 charge because gaining gives it 2 more negative charges.
So is it just trying to get to 8?
It's just trying to get to 8. Now there is an exception with like the first row and then part of the second. Let's look at boron, okay? So boron being element number 5, and let me go back to here. Boron is right here, okay, element number 5. So how many valence electrons does it have?
3.
It has 3. 1, 2, 3. So we can make a prediction about what charge it forms, but it has 3 valence electrons. So it can lose 3 electrons, or it can gain how many?
4.
Okay, 8 minus 3 is definitely 5. Okay, so which one's gonna seem easier? It's losing 3. Now let's talk about why that would make sense. So for boron, it has 5 protons, okay, in the nucleus. And so boron also has 5 electrons total. So remember, on the first ring, it's going to have 2 electrons, and then on its outer ring, it has 3. The outer ring would be the valence electrons. So what's going to happen is boron is going to lose those 3 electrons instead of gaining 5. When it loses those 3 electrons, y'all watch this. When it loses those 3, okay, that little purple circle that showed the path is no longer needed, and boron has a full set of valence electrons then, but boron just happens to only need 2 because that's the maximum on that first ring. Okay, so that first ring is the only one that is full and stable with only having 2. Okay, so boron makes a +3 charge by losing 3 electrons. Okay, and that's based on just losing its valence electrons. Does that make sense? So can y'all make predictions based on that? Okay, so on the practice sheet, it's going to ask you several questions such as what charge will a group 2 cation or a group 16 anion have? So I just want to show y'all what that's referring to. When it's mentioning the group numbers, I want you to look, and let me go ahead and erase this. I want you to look above, like just under these charges, and I want you to notice, yes, there are Roman numerals, and it has like A's on it and B's, but then even above that, it's got every single column numbered from 1 all the way to 18. So here's your best way to do this without having to think a whole lot, because if you can find a system that works without having to like really think hard about it, that's going to make your life easier. I need y'all to understand why, but it just makes it a lot easier if you can just like have a quick way to reference this. So this is group, whoops, this right here is group 1. Y'all see that? This is group 2. This is the same periodic table as y'all have, etc. The group number can tell you the number of valence electrons. So if we take all the 1s out of the double digits, okay, then the number that's left is the number of valence electrons. Do you see that? So that'll make it easier than even having to count and having to remember how to count this. Okay, so that's the number of valence electrons, but the question on your paper for number 1 under the critical thinking questions is, what charge will a group 2 cation have? So group 2 is right here. Okay, so what charge will a group 2 cation have? Well, it's given on your periodic table. It's a +2. And then when it asks about group 16, that's right here. It's a -2. Okay, so that's the main thing that it's walking you through. And then number 5 is a little weird. So let me find that slide. For number 5, I'm giving y'all the symbols of those elements because I realized after I had printed this out that it wasn't written in with the symbols. So it's going to take you a lot longer to find them if you don't know what they are. But let's do the first one. Let's do iodine. So I'm skipping to number 5. It's basically asking, it talks about lattice and all of that. Don't stress over that. We're not getting into that much detail. So for number 5, it asks, how many valence electrons do the following atoms have? Each one's going to have a different answer. And what charge do you expect each of the ions to have? So looking at iodine, how many valence electrons does it have? Iodine has 7. You know what? We'll do it like this. So for valence electrons, it has 7. And then for the charge, you can put that below it. And what's the charge of iodine? If you look at, that's 7 valence electrons, and if you look at your periodic table above I, it's a -1. Does that make sense? Okay, let's do one more. Let's do sodium. How many valence electrons does sodium have? Yes, sodium's number 11, and it has 1 valence electron. What is the charge given above sodium? +1. Okay, and that's all you're doing down the line. Okay, So that should get you through that first page, and then I'll make another video about some more of this packet.